Hello, everyone. Welcome again. So, our question was like, why we are only considering half of the node? Means if our size, so the size divided by 2, I is going to be the size divided by 2 to 1. Okay. So, if our size of the heap is 15, then we are going to considering the node with index 7 to 1. Okay. So here you can see that 1 2 3 4 5 6 7, these are the index. So 8 to 15, all the index we are just ignoring them. 8 9 10 and 8 to 15 we are actually ignoring all of them. Okay, so for the leaf node we don't have to actually do the heapify or parallocate down algorithm. We don't have to implement them. Okay, so the question was why we don't need them. So the idea is like as following. So they are the node with height 0. Okay, so what actually we are doing, we are considering to heapify each of the subtree. Okay, now for the heap, for the mean heap or max heap, we know that each of the subtree will be also a heap. Okay, so if we have a heap like that, say 2 4 6, I'm sorry, 2 is less than both 4 and 6, 4 should be less than like 7 and 8, 6 should be less than say 10 and 12. Okay, so that's the mean heap. So in this mean heap, each of the subtree will be also a mean heap. So that is one of the property. So what actually we are doing, in the reverse level order, we are actually heapify each of the subtree. Okay, we are making each of the subtree also a mean heap. Now if we consider all the leaf node, each of the leaf node actually is just a leaf node, only a single node. So each of the single node, they are already a heap. Okay, so they are already a mean heap. So node 73, it doesn't have any children, so it's already a mean heap. So each of the node in the leaf level, so all leaf nodes are already heap. Okay, so they are already mean heap or max heap. Okay, so they are already mean heap. So here we are showing you the example of mean heap algorithm. Okay, building a mean heap. So that's why actually all nodes in the leaf level, we are not going to actually consider them for doing the heapify or doing the parallocate down. So from the reverse level order, using the reverse level order in the bottom up approach, we are going to consider all the nodes in the bottom up approach. Okay, first we are going to consider 63, we are going to do the heapify, then 45, then 12, then 4. Means actually in the reverse level order we are going to do the heapify. So as the leaf nodes, all the leaf nodes in the leaf level, in the bottom level, they are already heap, then we are going to consider the level that has height 1. Okay, so this level, every node in this level has height 1. We are going to do the heapify for each of the node. So we'll make this subtree a heap, then we'll make this subtree a heap. So each of the subtree, we are going to make them a heap. So then we are going to consider this level. Okay, so means this this subtree will be heap, this subtree will be a heap. Then finally the root will be considered, and the root will be, we are going to make it as a heap, and then the whole tree will be a heap. Okay, so this is the reason we are not going to actually consider the any node in the leaf level. All right, now we are going to see the analysis of the build heap. So why the runtime is a linear time runtime. So in worst case, the runtime of this algorithm is order of n. Okay, all right, so forget about that. So without knowing the runtime, what do you think, I mean, based on your justification, do the analysis and what do you think what should be the runtime. Okay, so here what actually we are doing the parallocate down for each of the node. Okay, and we are considering like if you have total n nodes. Okay, so if we have total n nodes, then we are doing the parallocate, we are implementing the parallocate down algorithm with n minus 2 nodes. Okay, so means the runtime should be, looks like the runtime is the runtime of parallocate down algorithm means the runtime of Heapify. Okay, times n by 2. Okay, and what is the Heapify algorithm? So what is the runtime of Heapify algorithm? So runtime of this parallocate down or Heapify algorithm is actually depends on the height of the node. Okay, so depends on the height of the node. So for example, here for this node the runtime is going to be the height of this node, it is 1. So this algorithm depends on the height of the node. So the height of the node is actually in worst case the height of the node could be log of n. Okay, so seems like it should be also the runtime should be also n log n. Okay, so in worst case it is going to be n log n. Actually magically, I mean very interestingly, here the runtime is not n of log n. So here the runtime is actually linear time order of n. Okay, so the worst case runtime of this algorithm is order of n. So why is that? We are going to talk about that. Okay,